Already giving a presentation yesterday in some other session somehow. We will start the session now. Welcome everyone back from lunch. My name is Moritz Gold. I work for SuSanA, the Department of Water and Sanitation, developing countries at Lehrwag. In recent years, there were several projects and technologies coming up on energy recovery of fecal sludge, and that's what we're going to talk about today. Anaerobic digestion and specifically also combustion of fecal sludge, and how revenues from resource recovery can also go back into the sanitation service chain, maybe drive the sanitation chain, fuel the sanitation chain, offset treatment costs. So welcome and active participation from all of you. We start with our first presenter, Santa Berner, who is an environment engineer from Germany, but she's now living in South Africa. Her background is in integrated water resource management, and she's going to present how fecal sludge management can be integrated into wastewater treatment, wastewater sludge treatment, specifically co-digestion of fecal sludge and wastewater sludge. Santa, the floor is yours.
Hello. Hi everybody. My name is Senta. Thanks for the introduction, Moritz. And I'm from South Africa, from the Northwest University in Potchefstroom. And thanks to the sponsoring by the Bill and Melinda Gates Foundation and the Water Research Commission of South Africa, we are able to do a project on fecal sludge management. We just started, more or less, or we started last year, so we are right at the beginning of our setting up things, so just keep that in mind. Just an example, for example, when I switch on the water bath in my lab, then the light dims, so these kind of things are just things that we have to deal with. This is the team. Of course, I'm not working on that by myself. We are still trying to get more students. It's another thing. I don't know how it's at your university or research institution. Somehow the microbiology people that do the beer brewing get more students than us with the fecal sludge management, but we're working on that one. So our study area is the municipality where the university is located in. This is in Klokwe, local municipality. So when you think South Africa, that's these beautiful coastlines. There's none of that where we are. We are in the landlocked center or northern part of South Africa, not too far from Johannesburg. So that's us here. And our study area, you will see that it's a quite typical setup for South Africa. So we have a distinct urban center. Here, the town of Potchefstroom, it's a traditional sort of European-style town. Then the peri-urban environments or semi-urban environments around it with the townships of Ikageng and Starafina. And then we also have the odd rural village that's within the area of the municipality. Here's our wastewater treatment plant at the south side of the town. So surrounding us are a lot of farming communities and mining, of course, in our area as well, but relatively sparsely populated. So what are we trying to do in our project? We try to go to approach fecal sludge management in a holistic system approach. What you often find with environmental services on municipal level, we have a water department, then we have theoretically a sanitation department, but it means often because of these urban centers that have already centralized wastewater treatment structures, we have more a wastewater department, and then we have also the waste department. So where does fecal sludge management fit in? Basically, it's sort of a satellite, if it is at all within the ideas or the responsibilities of the municipality. They're often, or theoretically, it is a responsibility, but in reality, it is often just something that is solved ad hoc. So if there's a problem with a pit or something, then they try to do something with it, but there's no such thing as management. So we would rather have fecal sludge management as part of organic waste management, so that we go away from this whole sectoral thinking of this is water, this is waste, but look more at the resource streams or waste streams that occur within the municipality, and then address fecal sludge management as part of an integrated organic waste management approach. So how can you motivate a municipality? They never have money, right? They're always underpaid and overworked, and how can you motivate them to actually address that issue? So for us, our number one motivation, there are some others, but this is sort of the most compelling one, or seems to have the most impact, is we already have a large wastewater treatment plant with about capacity of 45 megaliters. And with all the aeration processes on the plant, you have these massive electricity bills. Yeah. So they spend about 2 million rand. That's I think $170-something thousand a month on electricity. So of course, for them, for the municipality, it is a very interesting idea to produce energy and not have a resource sink, but actually a resource source in their municipal infrastructure. And we already have these digesters, also very, very typical for South Africa. You go to these wastewater treatment plants, and they already have the digesters and the basic infrastructure standing around, but it has been dormant like for the last 20 years. So when you ask them, so what about these digesters? They sort of this double take, and oh yeah, we have digesters, and currently we fill them up with sludge, so it's a sludge retention system. Okay, so what is the first step when you think energy recovery? You have to know what feedstocks are available, because you want to make it interesting for the municipality when you think co-digestion, to also introduce other feedstocks. So what do we have here in our municipality is we have, of course, our sludge from the wastewater treatment plant. We have the fecal sludge from on-site sanitation in the rural village and in the informal settlements. In our semi-urban environment. Then we have the garden waste, food waste, waste from bakeries. We also have a lot of piggeries and broiler chicken production facilities, rendering facilities, and abattoirs, and the brewery. So these are the main producers for organic waste within our community. And when you look what's readily available without any hassle, that's the sludge from the wastewater treatment plant. The garden waste is collected separately, but then it already stops. So everything else already needs some kind of collection system. What is necessary, or where we put there should be a collection, is the fecal sludge from on-site sanitation. Because the pits are getting full, and yeah, as you probably heard already over the last 2 days, it's definitely an issue, and it's of course one of the core responsibilities of the municipality to provide adequate sanitation, which also means that they have to get rid of that stuff. Highly beneficial for biogas production, and with that electricity production, is food waste. However, it's not collected separately. Then when you look at the other major waste streams within the municipality, you see that a lot of things are already treated or partly treated, so private sector is very quick in finding solutions how to get rid of stuff and somehow making money. So a lot of these waste streams from these facilities end up as animal feeds. And then, of course, we also have sometimes just the volumes are just too high. So that would exceed the capacities that we currently have at the wastewater treatment plant. So there it doesn't make sense to introduce that and cause a bigger problem for the wastewater treatment plant, because of course the main obligation there is to have clean water at the end. So what that leaves us with is these 4 feedstocks that we are investigating, how they can be beneficial for in our case. And as I already said, the problem is here that the 2 of the 4 are not collected. So that's not a big bottleneck, actually the opposite, right? So that's a massive bottleneck right here at the beginning, at the collection point, when you want to have a system approach. So until you get here, there has to be a lot of things have to be already done. And at the moment, yeah, we're struggling to get this organized in a way. There are also a lot of cultural aspects with it, especially with collection from on-site sanitation. If you, for example, in South Africa, if you want to substitute the pit latrines with a container-based system, you already end up in a lot of trouble because of the former bucket system that was implemented by the apartheid regime. And when the aid word falls in South Africa, then the discussion basically stops. And yeah, so this is something you have to plan very, very carefully. But we are on it, just not yet very far. So, of course, then the next step, we want to investigate what are our feedstocks, what is the methane building potential. As I said, we are already only beginning at the moment, so we still have some issues with our analytics, and I rather skip that for now. Next time when we meet, I can present you wonderful results and beautiful graphs. For the moment, we only have that one. Now you see the variability within the COD levels in the fecal sludge. That's one of the things that we investigated so far and have also quite reliable results. Then, due to that, we also flew a little bit blind when we did our batch reactor test to test the methane production potential. But we did some tests on fecal sludge in comparison to sewage sludge. That's how the lab looks like. We use a displacement, liquid displacement setup, a UG-meter, in order to test the to capture the volume. No. Yes, that's the biogas production that we have so far. We found that fecal sludge performed a bit better, but as I said, we still have problems with our analytics, so I don't want to stress that too much, that point. However, at least we could find that there's no inhibition coming from the fecal sludge, so there's nothing that people just throw in that could cause a lot of trouble for the biogas production. And the next step for us is to build a continuously stirred reactor where we can actually test variation in feed, because one of the main things is that if you want to insert fecal sludge into the sludge volumes of the wastewater treatment plant, then you might not be able to do that on a continuous level. You will have maybe 2 collection days in a week, and then you will have the fecal sludge will be inserted in the system, whereas the rest of the time you won't have any fresh fecal sludge coming into your system. So for our municipality, when you look at how much money they have to take into their hands in order to just refurbish their existing digesters, it's already 28 million rand, plus the CHP unit. So that's a lot of money, and when you think that this system is, in this calculation, the pre-treatment of any kind of co-feeds and the mixing equipment is not yet included, simply that makes it a quite staggering number for the odd municipal official. So here, of course, this facility or these components have to be made feasible by the increase of biogas that you achieve. And at the moment, from just looking at the literature, you won't get that only by adding fecal sludge. So this has to be structured in such a way that you can also add food waste and then food waste or other organic material, but then, of course, the costs increase as well. So we are trying to get numbers to that, but at the moment, I think it will be a very small margin and how such a system can be feasible. But nevertheless, since fecal sludge management should be a core responsibility within the municipality, it's a worthwhile objective to look at. Thank you very much. That was so much from my side. As I said, we are on the beginning, so I hope that the next time we meet, I have some good things to tell you.
Thank you. Thank you, Santa, for the excellent presentation. We have a lot of time, so I ask the audience to ask questions.
Carolyn is from Sanitation. I'm, of course, curious to know more about the fecal sludge. I know you mentioned a little bit about it in your presentation, but like, how old is the sludge? How often are they emptied? What percentage of the city is covered by pit latrines? Are they flush toilets? Are they dry toilets?
Okay. Yes, thank you so much. The thing is, of course, that as I mentioned, that we want to have fresh fecal sludge because that has the highest potential for us. So with that comes that we want to substitute the existing ventilated improved pit latrines. At the moment we have this village that's about 250 pits there, and then we have in the informal settlements where there's no capturing of fecal sludge at the moment. So there's open defecation, there are chemical toilets flying around somewhere, and self-duct pit latrines. So there's also no clear idea how many there are because they are popping up every week, and then some are closing and so on. So it's a bit difficult to have a solid number with that. So this is also part of the investigation that is coming up now in February for us to do a survey in order to at least have an idea what volumes we're talking about. But the big issue is that we want to have the fresh fecal sludge. Fresh fecal sludge means container-based collection. So you won't get that from a pit because we don't want to really have the old sludge from the pit latrines because we cannot comfortably recommend a pit emptying strategy so far to our municipality, because the health risks are just too high and everything. So there's a lot of questions still. And container-based sanitation in South Africa, as I said, needs a lot of preparation and very, very, very careful planning. It cannot be stressed enough. I mean, we have, if people don't like it, tires are burning, national roads are blocked, and we had newspaper headings like the toilet war in South Africa and things like that. So this is then popping up. So of course, local municipalities, when you mention container-based sanitation, it's like, oh no, go away. So yeah, it's not that easy to address that. We started now with, we dance, we do music therapy. That's our approach at the moment. Yay! It works.
We demonstrate.
You do mirroring and stuff like that. Yeah, it's great, but also needs some improvement. Yeah.
Maybe that's something about next FSM conference to have an abstract on dancing for awareness raising and fecal sludge management.
Yeah, no,
We highly encourage that. Something new. Any more questions? Yeah.
Yeah, Dirk Walter from GIZ. I have a question. We have a similar project running in India. Moritz might even know it. My question to you is, you were emphasizing you need this fresh fecal sludge. And I'm wondering, because you talk about co-fermentation and knowing that usually the organic waste from other sources, especially kitchen waste, might be something else, is by factor 20 higher its biomechanization potential. It would not be so much particular if it's really fresh Faecal sludge or not. The reason why co-fermentation has an advantage lies more in some of the chemicals which comes along with the Faecal sludge and which accelerates the process. We did some investigation with the Böhler University in Goa on that issue, and we found roughly an optimum if we mix 1 to 1 or 1 to 1.5. That's one ton of kitchen waste and 1.5 metric tons of Faecal sludge. So my feeling is you should not be so particular that it's really fresh. Rather, what is more important at that point of time, at the stage where you are, to come up with a very clear operational model and also a finance model for the system. The operational model where you are able to fix the source streams. That time when we did our project, actually we were supposed to do it in Delhi, and we moved it to Nashik because we were not able to track the sources we wanted. And one factor you showed actually is a picture as a source, a pig. For us, a pig was a destroyer because in Delhi it's eating all the kitchen waste. They have huge piggeries. So we could not source kitchen waste for a waste-to-energy plant in Delhi, and we had to move to Nashik. Very, very important that you first solve this properly, because you go into the process, and at the end of the day it will not work because either you cannot tap the sources, you have not a proper operational system. Thank you.
Yeah, thank you very much for the comment. It's a very good point, and I hear you. Yeah, the food waste at the moment, the only accessible food waste for us, what we did in a screening, is the one from the business areas, the fast food restaurants that we have in the center of town that can actually be accessed, not so much from private households. That's basically, I would say, pretty much impossible to get food waste from local households for co-digestion. So the only thing that you can access is the cafeterias and fast food restaurants. That's what we are focusing on. Yeah. Thank you. But I would like to hear more about that. I saw the presentation about Nashik, but if you have more, bring it on. Thank you.
Okay, well, the next question. Thank you. My name is Amarge. I'm from Senegal, Sanitation University, and I work also with SuSanA. My question is, if you see the model, we focus also in solid waste and Faecal sludge. I want to know if the model focus only in Faecal sludge and the solid waste, it is an added solution to make going away this model, or just you focus only also in the Faecal sludge management and solid waste management?
We try to I'm not sure if I fully understood your question, but we try to combine, we don't try to think too much into what's municipal solid waste or solid waste and what's wastewater. We try more to look at the characteristics of the organic waste that occur on a municipal level, so that we can combine more freely the waste streams that make sense in order to produce the biogas at the end. So this, at the moment, we have at the moment in the first phase we looked only at Faecal sludge, but now my colleague Liani, she's starting with looking at the potential of the different other waste streams.
Thanks.
Okay.
Okay, well, the next question.
Okay, my name is Francis. I'm from Senegal. Okay, when you compare Faecal sludge with sewage, in what parameter was your base? The days, or what parameter was your base to compare?
What?
The parameter that you base to compare Faecal sludge to waste.
We looked at the methane production potential.
Yes.
So the fecal sludge performed slightly better than the sewage sludge.
Okay, in what parameter did you motivate? In the content of organic matter or?
Well, theoretically, CO2 and volatile solids, but we had some serious issues with our volatile solids analytics, so that didn't really work out. So at that point, it was more like, what does the literature tell us? So that's why I skipped over that a bit. Thank you.
Thank you for all the questions. Thank you, Santa. Santa representing me. Keep the other question for the panel. We're going to have more time later on. Thank you, Santa. I would like to introduce the second speaker, Dr. Sedunyan, who's leading the wastewater laboratory at the University Sheikh Anta Diop in Dakar, Senegal. He has 20 years experience in the use of wastewater in urban agriculture in Dakar. And since 2011, he's leading a research group on fecal sludge management located at the Cambrine Wastewater and Fecal Sludge Treatment Plant of owners in Dakar. The floor is yours, Sidhu.
Thank you, Maurice, for your presentation, your introduction, excuse me, and thank you for attending. Let me okay. Thank you for attending and giving me the opportunity to share our experience with you. We were trying to see whether fecal sludge could be used as fuel. And okay, thank you. We wanted to see whether using fecal sludge as fuel was efficient and then we tried to have this experience, and we wanted to share with you. Generally, when you see the use of fecal sludge and value, the mainstream goes to fertilizer, and the rest is landfill or incineration. Few quantity goes to incineration. But constant related now to regulations for use of fecal sludge or sludge in general in agriculture is giving an opportunity to use fecal sludge as fuel. More and more people are putting regulations for the use of fecal sludge agriculture. And for example, in 2006, the European Parliament saved 5 million ton coal and reduced CO2 emissions for about 8 million tons. This was proved. It was proven that using fecal sludge as a fuel is profitable. But did the calorific value of fecal sludge comparable to other fuels? We did the analysis, and we've seen that if you compare it to heavy oil, it's almost half. But if you compare it to other solid combustible, it's closely comparable. Now, just to set a picture of what is happening in Senegal, we are located in West Africa, close to the sea, and we have two nice sites where no problem for sanitation. Wastewater is sewage. But that areas where even they don't know what is fecal sludge, we have these sites where sanitation is a big issue. We are producing, likely in Dakar, around 2,000 cubic meters of fecal sludge. In Dakar, around 70% of the population are relating to on-site sanitation. But almost half of this stuff is, discharged into the environment. Why? Because of high cost of the mechanical empties. People are using manual emptiers to empty their pig or their laundry because of the high cost of this mechanical empty. How can we capture the amount of fecal sludge that is discharged by environment, and also the one we going to the treatment plants, which is also not really used. We thought if we use fecal sludge as fuel, we could then develop a strategy that can add value to the end products of fecal sludge, so that the whole chain of sanitation is there benefiting financially of this, and then we can then gather all the sludge and direct it to the treatment plant. To do this, we needed to target big consumers of sludge. We didn't want to just, do commercial and give it to low consumers. We targeted industrials. So those targets could consume a lot of quantity of sludge, and they can also put a lot of money so that the whole chain can benefit from it. Then we look for collaborators in the industrial tissue of Dakar. Then we found collaboration with an entity that called SRH, which is regenerating waste oil into original oil. One step of their process is to heat waste oil up to 360 degrees, using part of the collected waste oil. We saw providing adapting equipment we could use in this step of the process. We could use our dry fecal sludge to replace the existing food. To do that, we tried to design we designed to achieve our goal. We designed a kit. That is the first design we did. We have here a container that filled with cold oil, the waste oil, and this is the second container which is collecting the oil that is eaten. We have here here our chamber of commission drawer where we put our dry sludge, and we have ventilation to ventilate the process. But then, after few trials, we saw we need to perform our kiln, because we needed to have the oil preheated so that the flow can be go easily inside the kiln. And to do that, we needed to capture part of the fumes and direct it to the first container. We also wanted to measure the gas or the fumes we have out of the commission. Then we designed this bottle to capture and the fumes, so that we can measure what is going out. We saw also that if we want to target, if we want to have these companies with us on board, we need to handle nicely our Faecal sludge. So this is why we try to set a briefing machine, so that this is how looks our Faecal sludge if it is not treated, and this is how it looks like when we do our briefing machine. We have this kind of form, cubes, and we have briquettes. We measure also the calorific value of those forms, so that we can see if the different forms we have could impact the commission capacity or the commission results. This is what we had when we put in our kiln 5 kilograms of Faecal sludge. We burn them for 1 hour in the kiln. We've seen that we compare the commission of our Faecal sludge to commission of charcoal in our kiln. We've seen that for our Faecal sludge, we could reach almost 300 degrees, and we could set this temperature for about 20 minutes in the kiln. These are the two ways of measurement of temperature we did. We measured the temperature on the top of the kiln, and measured also on the bottom of the kiln. We measure also temperature variation inside the oil, inside the kiln. We also measured the residues we obtained when we burn totally our Faecal sludge. Compare steel to charcoal, we've seen that we have, for example, for the case you have 400 for 42% of the amount of Faecal sludge we put in our kiln, which is the remaining. part of this is we put the residue of the burning process in an oven with heating it for 3 hours at 550 degrees. This means that for the tubes, our kiln has burned the total burnable products in the Faecal sludge. But for briquettes and for cakes, still remains burnable products. We monitored also the gas emission in the out of the condition. We can see that if we compare what we have, we just monitor CO2 and humidity. If we compare what we have when we burn charcoal and compare to our Faecal sludge, we are quite less quantities of CO2 and humidity than charcoal. Then that means we are contaminating less the environment than that when we burn charcoal. In conclusion, this has demonstrated that Faecal sludge can be used as viable solid fuel. Performance of commission of Faecal sludge is comparable to charcoal. Faecal sludge commission performed right for greenhouse gases like CO2, humidity produced during the commission of Faecal sludge less than charcoal. Cement industries, waste oil generation, oven for batteries constitute a significant market that would provide incentives to production, transport, and treatment of Faecal sludge. I wanted to end here my presentation in thanking all those funders allowed us to do the research and bring us this conference. Thank you very much.
Thank you, Seydou, for this very practical example from Dhaka. Are there any questions to Seydou? You're the one in front.
Chris Abduti from Yamak. A question about the drying process before you can use it. Is that an additional energy input, or you just use solar drying?
Yeah, we use. Okay. Yeah. The transfer we had came from our drying beds. We just dry bed to dry Faecal.
Solar power?
No.
Solar.
Yeah, solar power.
There's one question from the gentleman in the back.
Yeah, thank you. My question was on health.
Can you please introduce yourself?
Oh, sorry. My name is Art. I work for SuSanA in the Netherlands and Ghana. I was wondering about the health impact, whether you had looked at that. Does like charcoal is very bad for your health? Yeah. I was wondering if you burn these briquettes, does it also have a health implication? But perhaps you didn't look at it. I was just wondering.
I didn't get the very well your question.
If when you burn the sludge in comparison to charcoal, are there any health
impact. Like if you burn charcoal, there's a lot of, if you burn in a house, there's a lot of smoke, which then has an impact on the health of people. Is that also a factor which you should consider for fecal sludge, or did you any?
This is why we compare it to charcoal. Anyway, people are using charcoal, and if they use our fecal sludge, they are less contaminated than they are using when they use this charcoal they are using already.
Did I answer your question?
Yeah, I think so. I'm just wondering why that is, but okay, that's the question.
I think also, like from the beginning of his presentation, when he said it's industrial scale end use. So we're not looking into, or he's not looking into using sludge in household level, but large scale industries, cement industries. Are there any more questions to say? There's also going to be an opportunity later on after all presentations at the panel. Thank you, Seydou, for your excellent presentation. I'm now going to hand over to Linda Strande from Sundeck because unfortunately Charles Niogam was unable to come, so I'm going to be presenting on behalf of Charles, and we don't want to have any conflict of moderation and presentation, so from here on Linda's going to take over.
Okay, thank you. I'd now like to introduce the next speaker, Moritz Gold.
That's a bit of a funny one. Dodgy. So I'm also presenting on fecal sludge to fuel, and as we already heard, industrial scale use of fecal sludge as a fuel. This research is coming out also out of the same project as the presentation Seydou gave. It's just a different context. East Africa, Uganda, different industry, brick company. And as I mentioned, Charles Niogam from Macquarie University was unable to come. So I'm going to present him and also his team in Uganda, Daniel Diba and Patrick Sechilongo. So that's Charles. So you have a face, so this face is, just imagine that's Charles now. And he's a senior lecturer at the Department of Civil and Environmental Engineering at Macquarie University. He's the person you need to contact or you need to consider when working on sanitation, grey water, wastewater treatment, fecal sludge management in Kampala. You might ask yourself why we are actually looking into using dried fecal sludge as a fuel. There's anaerobic digestion, there's there's pyrolysis, there's maybe hydrothermal carbonization, the different ways to recover resources conventionally used in agriculture as a soil conditioner. And as part of the FAME project, Fecal Management Enterprise Project, that's where this research and Seydou's research is coming out of. We're looking into what revenues, what amount of cash can you get in these markets for treatment end products. And if you look on Kampala, or in general, at the different end products, comparing the conventional end product, soil conditioner, and energy recovery options, so biogas, and using fecal sludge as a fuel, you see in Kampala that the highest potential was for using fecal sludge as a fuel and not as a soil conditioner. And this is because in Kampala a lot of the industries are already using solid fuels to meet their industry's requirements. So they're not relying on electricity or on oil, they're mostly relying on solid fuels. So on the top left you see sawdust, on the top right coffee husks, which are produced in Uganda, which is a big importer and producer of coffee, but also imported from Kenya and Tanzania. And on the bottom, the more conventional fuels, firewood and charcoal. This is the research kiln Charles and his team constructed in Kampala. It was constructed in collaboration with a local brick company. So in Dhaka it was SRH, this waste oil regeneration company, and here in Kampala it was a brick company. which needs a solid fuel, a dry fuel to fire bricks. So bricks are made out of clay, they dry, and then to get their final strength, they need to be fired at around 800, 900 degrees for a couple of hours before they can be sold and used in construction. And how this kiln works is that a dried, crushed fuel. So again, I try to compare with Sedu, different application. Here there's no use of briquettes or pellets. What the industry demands is a crushed fuel, which is here fed from the top into the kiln, and suspended combustion, so the fuel should directly combust in the air before falling on the ground. So again, this highlights that it's important to consider the demand of the industries and what kind of fuel do they need, at which dryness do you need to produce your fuel to meet the requirements of the industries. So I'm taking a step back. Christoph Lüthi was also already asking a question. A key in energy recovery is definitely how much energy does it take us to take Faecal sludge, which is, as you know, a very liquid kind of slurry, depending where you are. You saw in Durban, it's already pretty dry, but in both in Dakar and in Senegal, you're around a dryness of around 5%. So it's important that you find cost-effective ways to dry your sludge. And in Kampala, it was also done by solar drying beds at the Bubulobi wastewater treatment plant. And then by drying the sludge in the bed and crushing it with a simple crushing device, we ended up with the fuel on the right, which I think you can now imagine that Faecal sludge can be seen as a fuel and not like the stuff you see coming out of a vacuum truck. We are measuring the performance of the kiln both in terms of temperature, this is what's shown here on the slide, and in terms of product quality, which we're going to show on the next slide. So here you can see that there was a preheating period for a few hours, in this case a 6-hour period where the kiln was preheated. So it's a batch mode, usually in the industry it's a continuous mode, but as part of this research we constructed in a batch mode. And you can see at the point at around 2:40 p.m. we started firing Faecal sludge. You can see that Faecal sludge was able to achieve the temperatures required by the industry. On this slide, as I mentioned, we're also looking into product quality, because that's what Uganda Clays, the brick company, is always interested in, is that you produce the same quality brick product than what they currently have using coffee husks. In the beginning, they had quite some problems with achieving a good product. That's shown on the top right, like blackened bricks, or on the bottom left, broken bricks, because the combustion was taking place at the bottom and the bricks were breaking and they got black. But as you can see on the top left, by modification of the pilot kiln with the Ugandan brick company, we're able to achieve a product which is similar to the product shown on the bottom right. And we're still it was a pilot scale project, so we believe on the larger scale, when you can really run your kiln continuously, and it's run by the Ugandan brick company, we believe that you can achieve the same product quality. Talking about the financial potential, or can it actually also be a financial incentive for Faecal sludge management, I try to give the example of coffee husks that's often explained when you come to Uganda. Coffee husk was a waste stream some years back, 5-10 years back, and it was only used locally in Kampala, so it wasn't imported. And now in Kampala, it's a resource. It's traded at around $30 per ton. You also get higher prices depending on where you try to buy coffee. So we believe it could also be a scenario for Faecal sludge. And when comparing the revenue potential, so here we only talk about revenue, we're not talking about profit or production costs of this fuel. We really talk only about theoretically what could we get comparing salt conditioner and industrial fuel, and also different scenarios, because at the moment not all sludge which is generated is treated. and neither collected. But in general, big picture, we can see that the revenue potential is approximately double as high if we use fecal sludge in industries as a solid fuel rather than using it as a solid condition agriculture. We had some challenges. It's definitely, we're not presenting any one solution. And these three challenges were that there's a high moisture content, so it's a challenge to dry sludge to 90%, that's usually the degree required by industries. We have a high ash content, so ash is defined usually as the residue after combusting it at 550 degrees in the laboratory. And this was also done, this laboratory was also done by Hima Cement, a cement company in Uganda. And they said, like, product is interesting, but the ash content was so high, so that's what future projects should work on. And what also came out of some financial calculation was that there were actually low fuel quantities. So we kind of aiming for industrial scale end use, so there's like a huge demand of product, but actually the amount of sludge we can produce or sludge fuel we can produce actually quite low. So if you have a brick company or a cement company, then they need, I don't know, 200, 500 tons of fuel a day, and you turn up, okay, theoretically at the collection rate at the moment and treatment capacity, that can produce, I don't know, half a ton. It's not really attractive for them. So these are the kind of challenges we overcome by a future research project, or a research project we started in September, also in Kampala, in collaboration between Makerere, SUNDEC, and different projects part in Uganda, looking into pelletizing and gasification of fecal sludge. So pelletizing because we found a Swiss engineering company who can already process the fuel at fecal sludge as a drying of around 60%, which significantly reduces the need to dry the sludge to 90%. And electricity, simply also because we made some calculations and we think that has a higher kind of product price compared to fecal sludge as a dry fuel only, so it's kind of increasing the product the price. And as already mentioned in the previous presentation, looking into co-processing of fecal sludge and other waste streams, so to increase the fuel quantities, but also increasing the flow, the fuel quality. So I think that's something which I also got out of the first presentation, that we need to co-manage different waste streams to have fecal sludge management or waste management at scale. I'd like to thank all our project partners, both in Uganda and also in Senegal, and the funding supplied by Splash, Synthesis and Rapid. I'd like to highlight the resources SUNDEC is providing. So all of which are presented here and Satan presented before is available on the SUNDEC webpage, and we also have a SUNDEC YouTube channel where we last week published a video about the project. Thank you.
Thank you, Moritz, for a very interesting presentation. I'd like to invite a few 2 or 3 questions from Moritz, and then just briefly have a panel discussion. It talks about how all the different topics also are interrelated. So we'll just take a couple questions from Moritz, and then we'll have Senta, Seydou, and Moritz all come together. I see Allison already has a question in the back.
I was really pleased to see the results you got from the bricks when you finally kind of optimised the system, but you said you had to do some modifications to the kiln to get to that stage. Can you expand a bit on what those were?
Thanks, Alice, for that question. I wasn't directly involved, but I think it had to do with releasing, controlling the heat in the kiln by a mechanism in the chimney. So before the heat which was generated in the kiln was just directly going out of the chimney, and then they had like a metal plate where they can kind of control the heat in the chimney. I think that's the change they made. The first and the second was making the fuel a bit finer. So it was a challenge to kind of crush the fuel, the fecal sludge, because there's also stones or I don't know what in it. So there was also a challenge. So it was also making the fuel finer, so it really combusts in the air.
I thought that was one interesting thing when I went to see a demonstration at the kiln, that they drop the fuel in from the top, but it actually has to combust before it hits the bricks, otherwise it can discolor the bricks. Do we have another question here?
Yeah, two short questions.
Sorry, I know you already asked a question, but can you please also start out by saying your name and who you're with?
Yeah, Dirk Walter. I have two short questions. One with regards to moisture content and transport, which are closely linked with each other. Did you do any study? What is the economic feasibility if you use any combustion process, especially with the industry? That means you have to look into the distance, you have to search for industries. And secondly, the previous speaker was, to my surprise, talking about a lot of inerts in the Faecal sludge. Did you observe it similar? He talked about, I think, up to 20%.
So inerts in the sense of ash. So not combustible.
Yeah, scent and ash.
Okay. Thanks for your question. So both in Dhaka and Kampala, where the pilots were the sludge is collected from households and then transported to a centralized treatment plant where it is treated, which means dried, the effluent is treated, co-treated with wastewater. So you at the end dry there the fuel and transport it to the industries. So there is no, I mean, you could locate the treatment plant directly next to the industry, and then you don't have this transport cost. But I mean, in terms of what I was presenting, the second last slide, where we now pelletizing fecal sludge, there we're looking into densifying the fuel and making a fuel which is easy to transport to decrease the cost for transport. But at the moment, also in Kampala and Dhaka, we're looking into industries which are closely located around the treatment plant. And in terms of inerts, yes, we had there were the same observations in Kampala, where ash contents were up to 40%. And that's obviously undesired by industries because they need to dispose them, and it doesn't decrease their disposal costs. Unless you have a company like Cement Industries, which maybe can include the ash in their final product, but then the composition of the ash really needs to fit to their fuel mix. Like, do they really want to have all the components you have in your ash? Do they want it in their product? And phosphorus, for example, is something undesired could be undesired by Cement Industries because it changes the binding behavior of the cement. So that's really where you have to work with the industry to find the right kind of mix.
Great, thank you, Moritz. Can we all say thanks again to Moritz for his presentation? Then I'd like to invite Moritz to stay here on the stage and also invite Senta and Zaidu back up. I think this whole session was about fecal sludge to energy, but it's interesting because it was two really different types of technologies and then also two more similar types, but in quite different applications in different regions. And I'll just ask a couple questions, but anyone from the audience is also welcome to ask any questions, either to the whole panel or to any of the individuals. I think it's interesting. I would like to know more about the co-management with other organic waste streams. That was something that first Senta brought up in her presentation. I mean, it's something we looked at here in Vietnam, but actually other waste streams weren't available because they were already being used. And then Moritz also brought it up a little bit, and I just was wondering if you could each talk briefly about where you see the fecal sludge fitting in with treatment of other waste streams. Okay.
I mentioned that our number one motivation for our municipality in order to address fecal sludge management is the energy recovery. But another very important one is when you mention landfill site, headspace, and landfill site lifespan. These are also some words that always go very well with the municipality and make them become more interested in what you have to say. So we have a big problem with garden waste bulking up our landfill sites in South Africa. So if we somehow can find a usage or utilization method for the garden waste, in particular tree cuttings, then that would also help a lot. And therefore, it's
it's one of the often also readily available resources that organic waste streams. However, for anaerobic digestion, now in our case, it doesn't make as much sense because it's blocking up also the digesters. So for us, it's more in the field of composting together with digested sludge. That's what we are aiming for. But I think, yeah, this is also, it often makes sense to look at the whole system so that you can identify what other things can be of interest for the governments of the industry.
So we have currently a project assistant working on Kampala and kind of identifying waste streams that could be co-processed with fecal sludge. And a preliminary finding was kind of that the low-hanging fruits, like the nice waste streams are already taken. You're ending up with like wastewater sludge, which then has like heavy metals in it, which can have a problem for your process. You have water treatment sludge, which they use conditioners and chemicals. And you have abattoir waste, which is then also has health implications. But we also identified some waste streams like market waste. There's a huge amount of market waste in the order of like 500 to 1,000 tons per day dumped in a landfill. And there's only a few percent, 1-2% of innards or ash in these market waste. So I think there's a high potential of co-processing. And also in Kampala there's a like when we were talking to KCCA, they're very much interested in combining these waste streams. And I found the question before of Amadou from Senegal, I found it interesting. If you're primarily interested in fecal sludge or if you're interested in solid waste. And I guess the success to co-processing is you kind of have to be interested in all of it, which is difficult because we usually think in these projects and programs, and you have a fecal sludge project, and you have a wastewater project, and you have a market waste project, but somehow we need to see it more holistic to really manage all of them and be successful.
Okay. There's no immediate questions from the audience. I just want to be a little bit controversial. I think that's always good for a panel discussion. Some people would criticize your work, not as much SENTA, but the other two of you, because you're not taking the fecal sludge, which is rich in organic matter and nutrients, and using it in the soil. I'm saying not because of you, because you could actually use the digestate for that purpose. So I'm just wondering what your thoughts are on that subject.
Okay.
I think the battery is good on that microphone.
So far, the use of Faecal sludge in the way of as fertilizer worked well, but it didn't significantly influence the business all along the chain of sanitation. The price you got from fertilizer is very low. If you want to scale up, I think we need to think about another way of using that sludge. And still, we have demonstrated when we did our combustion that out of the combustion, you could have still some usage for fertilizer. You have the residue of combustion can be also used for fertilizer farms. You can benefit them on the two ways of valorizing.
So you have the phosphorus and the ash in addition to the fuel potential.
So I think we're not promoting energy recovery as the solution. We promote it as one solution. Combustion is one solution. And it might not make sense for another area or areas where there is really a high use of fecal sludge in the soil conditioner. But what we saw in our study is that at the moment the treated sludge is simply not used. And this can be to various reasons, but we think one reason is that there's not a strong enough drive or a strong enough revenue potential. And the second thing is, I mean, in the next, I don't know, 5 to 10 years, these technologies are going to come up where we can recover phosphorus from wastewater treatment, sludge, and well, I think what studies showed is that it's actually it's going to be most economical to recover phosphorus from the ash because there it gets concentrated, and then it's much more economical than recovering it from a raw product. So mono incineration or mono combustion could be a way to recover phosphorus.
Great, thank you. So you guys also brought up another point that I was interested in, is that you're talking about resource recovery and the potential financial gain. And I know you talked about the different value of different resource recovery products, but I was wondering what each of you think the actual contribution could be to actually getting more financial flow through the entire sanitation service chain. I mean, our goal is to ultimately potentially lower costs at the household level so that more people will get their system emptied and that sludge is removed from the community. So I was wondering what you think is the real potential for resource recovery to provide financial revenues in the sanitation chain.
So, I think there's always going to be investment costs or capital costs which are very high and going to be covered by donors or by governments to provide centralized or semi-centralized facilities, container-based solution. I think also their technologies are expensive, besides maybe composting. But still, there's a high capital cost associated with it. But I believe that, or I think, from my experience, the resource recovery can contribute or maybe fully cover operational costs of fecal sludge treatment. What I find interesting we were working together with a utility, and a utility usually doesn't have, or like historically, they not have the capacities to sell a product. And now often we want to tell them, oh, you have to market your product. So, I don't know, maybe private companies may be used to it, but private companies are not used to treating fecal sludge. So, maybe utilities need to we need to have a strong emphasis on enabling them to kind of have a marketing department or a department which continuously works on a strategy for resource recovery, and not only for treatment or running a treatment plant, but also like how can we kind of meet the demands of our end user. Because if you sell a product, that's continuously what you have to do. You have to convince your end user that you can produce a quality product and sell it to it, and then you also get something back, which you can use to cover treatment costs.
I just want to add something is, something in Senegal is cooking now, because treatment plants, fecal sludge treatment plants are privatized. And yesterday, mine was responsible of this issue, was saying that these companies, since there have been privatized, they are doing benefits. If now we approach these private people to tell them that the end product can be reused, can be valorized, I think it can be quickly and impact quickly the whole chain.
I have a couple of questions from the audience. I can't see very well. Is that monkey back there? Yeah.
First of all, thank you very much to all the presenters. It's good to hear a lot about resource recovery. I'd like to be a bit more practical. in the perspective with regards to resource recovery. For me, I think mine is a comment, it's not a question. I think the issue is understanding what works with, what kind of solution is feasible with, who needs what kind of product, for what kind of business enterprise, and what kind of business model should support that. I think that kind of thorough analysis is what I find a bit missing in the whole discourse on resource recovery. So it's not so much about fuel use is better than agriculture or agriculture is better than fuel use, but it's like in that context, what is the feasible solution that can contribute to generating revenue to support the whole sanitation chain? So I think in our presentation of our solutions, we should look at it in this perspective rather than one is better than the other. Thank you.
I would just like to say I think that's an outstanding comment. Thank you for that contribution. Actually, I'd just say it's something that we're working on a little bit at SONDEC. We're what we call our market-based approach, where we're working together with economists and experts in business models, because I'm an engineer and I don't understand all those things necessarily so well. So we're going into cities and saying what is actually the biggest market demand, but also factoring in social acceptance, things that are subsidized, looking at all of those things together. And one of my big soapbox issues that I'm going to say, just because I have the microphone in my hand and I can say whatever I want, is that we should decide what the end goal is for treatment, and then as engineers design the technology to meet those goals. So we don't want to over-design things and waste money, and we don't want to under-design things and then risk public health. So if we're talking about resource recovery, I think that's really important, that we design the technologies appropriate for the end use. So I'd like to turn that into a question to the panel, is that one thing I noticed was that mostly what you were talking about was taking existing technologies and sort of retrofitting them and trying to increase the resource recovery. So if you had the other option and you could just walk into your city and design from scratch your treatment system for the resource recovery product that you wanted, what would you do differently?
Yeah, wow, that's starting with a clean plane is not always the easiest, right? We have, I think a big thing is to achieve acceptance. I think this is also one of the reasons why we always go back to the systems that have been already in use. Because I know when I discuss with our counterparts in the municipality any kind of new technology, they look at me and it's like, oh, you know, look at her, she's dreaming. And then there are like engineers that have studied, I don't know, 50 years ago, and they want to have the stuff that they know. So anaerobic digestion, when you talk to the people from the wastewater treatment sector, it's something very straightforward and easy to sell. So for me, just because the municipality at the end has to do the job, I probably would go for the same strategy for the anaerobic digestion, simply because it's something that can be sold. Exciting, I find anything that's where you use solar power, solar paralyzers, things like that, that I find, especially in the African context, very, very useful. However, it's much more difficult to sell it to the local decision makers.
I think talking directly to private people that is already doing business is a important, way to use our material. Recently, we work in this issue with the Polytechnical School of Chess, and they invite me recently for a defense of one of their students. This one was using our kiln to burn bread. The bread was
to bake bread.
Yeah, bake bread. And they invite the president of the Association of Bakers of Chess. the bread was not good because in designing the system, they didn't involve a baker. They could cook bread, but they couldn't. They didn't know how to cook the bread. But those people are now, aware of this system, and they are approaching the polytechnic school to work with them, to put they were volunteers to put one worker to show them how to cook well the bread, so that if it works, they can, because these people, they want to buy the bread and they want to make money. They are using fuel. In Senegal, we don't produce fuel. They import it. So if they know they can reduce their management operational, how can I say it, way of producing bread in using as entry point as fuel Faecal sludge, which is going to cost less than the fuel. It will go back.
This is really an example of a closed loop using fecal sludge to produce your food. Yeah. Are there any other questions from the audience or comments? We have one there.
Hello, I'm Santiago from Policy Research Group in Durban. I have a question for the combustion, or for maybe one of two. Have you studied the nitrogen content? Because I'm afraid that when we make the combustion, there is a lot of nitrogen, we can form NOx. So you say that is less pollutant than charcoal, but charcoal has less nitrogen. So this can be a problem, a very local environmental problem. So do you measure it, or do you follow it? And second thing, maybe it's possible to use charcoal to make pyrolysis the wood. I think with the pyrolysis, the nitrogen would go in form of ammonia, most of the nitrogen, and because when you pyrolysis, you are concentrating the carbon. So maybe also you can try to do that. Thank you.
Okay, those are two really good questions that are very relevant. Let's take them one at a time. The first one is about nitrogen in the fecal sludge, and then when you combust it, you could create nitrous oxide or the NOx compounds. And have you addressed that, and what do you have to tell us about that?
Unfortunately, we didn't follow this because we didn't have the equipment to follow it. But it is our goal to have these materials for following nitrogen in the field.
Lawrence, do you want to add anything?
We took some of the sludge from Dhaka and from Kampala and analyzed it for the elemental composition. And comparing the nitrogen content, I don't have the number in my head, I can tell you afterwards, or tomorrow at the resource recovery workshop in the afternoon, I'm going to give a presentation where we discuss a bit about heavy metals and nitrogen and phosphorus and chlorine, these kind of things. Comparing to other fuels, the nitrogen level was not significantly higher. What was higher was sulfur and phosphorus, but nitrogen levels were not really high. But what we see as one advantage of using it in industries that they have usually filter systems to clean emission, like to get rid of emissions from combustions. Like cement companies, they use, in Europe they use waste like paint and, I don't know, slaughterhouse waste and these kind of things. So fecal sludge in a way the emission should be lower, I would say.
I think they both mentioned that that's one reason why they're not looking at using briquettes at a household level, because of these direct human health concerns. So maybe at an industrial level, it's something that could be managed better. So he had a second question, and that was and maybe looked at pyrolysis and the fate of nitrogen in pyrolysis versus combustion. No is also an acceptable answer.
We didn't. Talk to Climate Foundation, Brian van Hersen, he's here, he should know more about that.
Great, do we have any final comments or questions? Here's one right here. Sorry, I can't see so well. Can you please also say your name when you...
Yeah, thank you, Mr. Chairman. My name is Usman Sow. I come from Senegal. I have two questions. The first, for the next step, have you possibility to develop research to understand more the market, to analyze the situation, the actual situation for the offer and the demand for fertilizer? Because if you want to scale up and to develop fecal sludge management, I think we must demonstrate the profitability. And if you want to demonstrate the profitability, we must demonstrate the development of the reutilization for fecal sludge management. Also, I think it is very important to make the focus in the communication, to understand more the barrier for the reuse in the population. If we know that the products have some fecal sludge ingredient, and it is also very important to understand in the population what is the problem to reuse this product and how to resolve this problem also. I think it is very important to develop these two components. Thank you very much.
Yeah, those are both very excellent comments. So I think I would break it down into two different parts he was talking about. One is specifically market demand and what kind of revenues can be generated, and have you studied that? And then the second one was what about cultural acceptance and the end use of fecal sludge derived products, and how are you addressing that?
I like that one because I have like 25 years experience on the use of wastewater in agriculture. And talking about the demand, there is a use in Senegal, a huge package of alternative, organic fertilizers that people are using that are so low cost, like shells, peanut shells, like fish. We have a lot of fish in Senegal. The fish residues, they have a lot of, alternatives, and fecal sludge is one of them. Most of them are using already for acceptance of fecal sludge as fertilizer. Most of them are using already raw fecal sludge to irrigate. So dry fecal sludge is not a problem. It's there. They have a demand. The demand is there for fertilizer. But the money you can get out of it is so low that I think we should try to focus on other streams of consumption of our fecal sludge if we want to impact significantly the chain of the whole chain of sanitation in Senegal, for example.
Hey, Usman from Senegal. Did Senegal answer your question? Does anyone else want to comment?
Maybe also an experience from Senegal in terms of end user products. The cement company was not really willing to accept the value of the sludge. So they were willing to accept it, but they were not willing to pay a price for it. So I think it's important to kind of bring industries on board and bring it to a not to a full scale, but to like a pilot scale that you produce some fuel and you work with the industry. They have some trials. First of all, maybe it's not going to work, but then go back and forth and like convince them that it's a viable fuel for them and that they should pay a price for it.
I'd also like to just comment briefly on that because I have a slightly different interpretation from my conversations with the cement factory. They actually realized there was a potential value in the fuel, but they didn't want us to tell people because what happened was when they started using other waste products like brown tires or peanut shells or all these different things, people were just dropping them off because they were a waste that they had to get rid of. But once they found out that they had a value, then they started asking money for it. And then the cement factory has to pay for it. So they were also, you know, if we were going to have them use fecal sludge, they wanted it to be sold as really a public health benefit so that in the future they would be able to use it without having to pay for it. So, but of course we want people to pay for fecal sludge. I think Charles Niwagabu, who's not here, had a really great line at one conference. I heard him say that one day soon fecal sludge is going to be so valuable that people are going to be breaking into your house and instead of stealing your money, they're going to be stealing the shit from your toilet. So, hopefully. We have a comment here.
Thank you very much. My name is Nkeze Mechembe from the University of Yaoundé in Cameroon. I'm particularly interested in the products of incineration. That's the ash. I remember when the last presenter was speaking, he mentioned something as the management of the ash being one of their preoccupations. And it happens that I'm working with wood ash, so I wanted to find out. First of all, did you analyze the ash to find out its content? And secondly, what were the options, if any, that you exploited for the reuse of the ash? Or if you did not reuse the ash, what happened? How did you dispose of it? Thank you.
That's a really good question. I think I would also add, if you could just in general clarify for people, because you're always, I think, working in the sector using the terms, you're always using this much ash, that much ash, and if people aren't working with the fecal sludge as fuel, or maybe don't understand exactly what that means.
Thanks, Nkeze, for your question. So ash is in general just defined in engineering as a term what doesn't, like the residue when you combust your fuel at 550 degrees, but ash can be very different depending on, if your combustion process below these 500, you have residue which still contains organic material. That's what I think Sado highlighted. We didn't analyze the ash, we analyzed the fuel as I mentioned, and we can have a look at the composition. And from there you can see what's gonna stay in the ash, phosphorus and heavy metals. You're asking specifically also about magnesium.
Yes.
For struvite precipitation. We should have a look, yeah. That would be a nice closed loop if we can take the ash and precipitate struvite from leachate or drying beds. So in the study we didn't have a significant amount of ash because it was a pilot research project, but we think it's something important to consider when going full scale.
Did anyone else want to comment? I think also one thing to consider is that if you have to manage some ash that does have some toxic compounds in it, it's such a smaller waste stream and so much less likely to contaminate the environment than a huge amount of liquid fecal sludge, which could go directly into the environment. Do we have any more questions for the panelists? Could we take one more here at the front?
Okay, my question was...
Do you want to first say who you are for everyone, please?
No, I'm just...
This is Alsan
from Senegal. Okay, I would like to... I have just one question for Maurice. Because in Senegal, when we burn the fecal sludge, we wait maybe 5 plus kilogram fecal sludge we burn with, for one hour. When Charles does his experiment, did he interested to for fecal sludge that we want.
Do you understand?
So also was asking if Charles in Uganda measured the quantity of fuel used in each of these trials, because in Dhaka they used 5 kg, and you were asking how much Charles used. It was, I don't know the quantities, I think they calculated it in bags, but it was significantly high. I think it was 5-6 bags of each, like 30 to 50 kg.
Because in case of replication, is it possible to, at that you will recommend this kind of material for money? Is it possible to recommend this, because we do not give the mass of sludge?
I talked to Charles about this issue, and of course they have. They know which quantity of sludge, dry fecal sludge they need to reach the amount of temperature they need to have. They have all those figures. They know.
But it's also difficult to compare between Dhaka and Kampala because of the different kill design and the volume.
Okay, I think this is a good point to go ahead and wrap up the conversation today. I'm just going to ask the panelists if they have any last comments that they would like to make quickly.
I brought some fecal sludge pellets along, which I have from my bag from Kampala as a gift from Charles to you, so please come along and get some. Thank you for the active participation.
Yep, fantastic. So we're going to wrap up this session a little bit early before coffee break so that we all have time to touch, feel, taste, and smell the fecal sludge pellets in person. Then we have a coffee break and then our final plenary session, and we hope to see you all there. Thank you very much for your participation and for attending.